Hello. Today I will walk you through how we can create a simple iris classification project using the Dhaani-iProg tool. Um, there are already a few demo projects in this tool when you load in, but the iris dataset is like the hello world of the data science world. So we will start with that. What is the Dhaani-iProg tool? It basically helps you create an end-to-end workflow of your project in a two-step process. One is it helps you structure your solution in the form of data flow diagrams, and then it will go in each of the process of the data flow diagram to generate code for each process and then bind them end-to-end together. This is not an automated solution, but it's very much an interaction with the large language models. It is very much a human in the loop. And you as a user maintain full control over the progress of how the solution is being developed. So let's go ahead and create our Iris project. This is a classification project. The project specification is important because this is what actually goes to the large language model to create the data flow diagram. So I want to classify the iris dataset, okay? Path to the dataset. So let me just get that quickly. So I have my dataset in CSV form over here. Project type is machine learning. And I recommend the UV project manager, package manager. You don't have to do anything for managing the packages. It will do everything on its own. So we have this iris dataset created over here. I had one created earlier as well. So that's why you see two of these. Oops. So we can use the AI to create the data flow diagram. And this, what you see over here is the main space where we create the data flow diagram. We can have processes, we can have data store and data stores link to process, and you can put in more details. So for example, this process could be loading the data set. We can have another process which then creates train test split, and then another process to actually train models to be able to classify the data set. So I can do all of that manually, and I can also like put in details for each of them. So I'll just delete the data stores and processes because I want Kickstart to start with. So I can create this data flow diagram directly using large language models. And it takes a few seconds. So once you create it, also you can do a lot of editing, which I will show you. Just to walk you through the tool, this is where all your modules and processes will get listed. You can save the data flow diagram over here. If you delete a module, it goes in trash and you can restore it from there. So, right. So this is the data flow diagram suggested by the large language model. I can interact with it to modify it. Let's do that actually. So if I refute this, say, all right, I agree with ingest iris data, then you pre-process the data, you want to train the classifier, and then I'll go ahead and classify the new iris samples. And it should load the raw data set from here. So the raw data set should already be there in the location. I don't see the use of external entities in this particular end-to-end flow, other than like actually starting the flow, but that's not what external entities actually do. So maybe I might say that I don't need the external entities in the diagram. Also, it makes sense to have a location for the raw iris dataset from where I will actually load it. Do I really want to store the pre-processed iris data? I don't think so. Train classify model is okay. And storing the classification result, let's keep it for now. But I'll show you how I do that manually. So I'll submit this feedback. And so I'm refuting the current solution given by the provider. So as you can see, the interaction is also quite structured. It's not, it is free form. We interact in natural language, but there is a structure to it. So we have this raw iris data set now. So it loads the data. It has done something to this. So it is after loading it, it saves it over here. So let me ratify this. Okay, and you will see that all details have also come into this. The raw data set is being read from here. I have another place. So I have a dedicated data folder where the iris data set is there. So I will just read it from there. I can modify the location over here. Let us save this. And of course, if I wanted to modify the specification, I could do that also. I by mistake double clicked on the module. So what you see here is the module page with all its specifications. I can chat with a large language model, and this is like any other chat platform. It's just for exploring. And then I can go in the structured interaction mode to actually generate the code. We'll do that in a minute. Before that, let me go back to the project. And as I was saying, I did not want this pre-processed iris data to be stored, so I can just delete that. And what I have now is I would load my iris dataset that gets stored in raw iris dataset, and then we go to clean and process data. Also generate iris predictions. So the raw data goes over here, this goes over here, and we also need to train. And the after cleansing and pre-processing the iris data is that data is what I need to train. So let's say this is pre-processed iris data. So this is what is happening. So then we train it, the trained model gets saved over here. And what is it saving as? It is correctly saving it as a pickle file, so that's good. This should load the pickle file and along with the sample data, generate the classification results. What I can now do is just click on generate code and it will just go through the whole data flow diagram and generate code for each of the process. And then I can open my IDE and verify it. That's the fully automated kind of thing. At the moment, it needs certain tweaks, so it will invariably lead to certain errors. So best what we can do is go to each module and go in the structured interaction mode, and I start the session over here. So what this does is it takes in the project specification, it takes in the module specifications, the preconditions, post conditions, it takes in context from the rest of the project and tries to generate code accordingly. As you can see, it will take in the data stored location, which is already saved by the application. And the actual data locations never get sent to the large language model. I can try to run the code from here itself, or I can also open this application in an IDE. So validation complete, all rows are valid. It also auto installs packages if they are missing. Now, this is a setting you can turn off in the project settings if you don't want. All right, I removed that for now. But if there are specific packages, so it will auto install packages if they are already present in your base Python environment. If they're not, it will actually ask you if you want to go ahead and install those packages. Um, So validation, all rows are valid, it is saying. So let's say submit feedback. I agree with the code. I agree with the explanation. It will always give output in two parts as the code and the explanation. And I can disagree with either one of them. So when I get back to the project, load iris dataset, the code for it has been completed. And I can actually open that project here. And I can see this is the load iris dataset. So now if I want to tinker with it over here, I can do that. I can run the code over here as well. So for those who are more technically inclined and more hands-on, you can actually come here and do things. So in this manner, I can go in each process and generate code for it. I can also click on generate code, which will automatically go to each of these processes and generate code for it. So if I see here, this has changed based on the latest code that is generated from here. So you can see code is getting generated. And I can run each of this code and check it out. So let me do load iris. So it has successfully generated code for all the 4 processes. What I clicked on OK and hurriedly was just saying that there might be errors. So best to check. So I run this load iris dataset. As you can see, the output is a little different because it auto-generated and created a new implementation. Next, we have cleanse and pre-process the iris dataset. So I'm hardly going through the code. I am just running it to for a sanity check to see how it works. Then we have the train iris species. And if I'm not happy with it, I can double click into that module and go inside that module and interact with the large language model to create code. So this might seem a little cumbersome for such a simple project like the iris dataset, but it is very useful when you have an actual real world project. So for example, I solved the IProg challenge using this approach, and I didn't even have this fancy UI with me at that point in time. But I encourage you to try some Kaggle competition with it, where you have more complex and integrated data flow diagrams, where you will need this sort of a structure. Okay, so this is done. Train, let's see, train. So if I look at the imports, it is importing load iris dataset, and then it will go ahead and train it. And this should actually generate a pickle file and store it in data. There is some error. So it did not find the preprocessed data path. It was expecting. Okay, so it has assumed, because this is a process to process flow, it has assumed that the process has created some artifact and stored over here. What I will do is, so let's train it on this raw iris dataset location. And if I do that, sorry. Yeah, that was right. It should actually be species and not class. This is why I don't like the auto-generate code, because invariably you do have to tinker around in the code. Yeah, so it generates this, and in the data folder, it has saved the pickle file as well. And the last one is generate iris predictions. If I just run it. And it creates the predictions. So in this thing, I'm not really going into the correctness of the code and everything. It's just to show that end to end, it works with minimal interaction. Just within this small time, we were able to do this. And this would make sense like for a person who's just starting off with their machine learning journey and want to try things out. This gives more of a, with the iris data set, of course, this gives more of a hold of what is happening where. And say you want to modify the train iris species classifier because it was using, let's see, what was it using? I was using the random forest classifier. Say if you want to use something else. So I can modify that in the specification. Let's edit the specification. Algorithm such as logistic regression fits the model, evaluates the performance. And I'll just say use the support vector machine model. And let's start this session. See, trains a SVM classifier, and it's using SVM. So I'll just agree with it now. I can interact with, I'll show that in a separate video of how we would interact within a module. Now, if I go over here, and this has changed to training a support vector machine classifier. So this is the iris cleaned earlier that we had, yeah. And it is expecting label this time, but the column is species. So this ran, and now we have just changed the train iris species classifier code. Let's see if generate iris predictions will also work as before. Okay, so the SVC has no attribute predict probability. So sometimes the processes are very much dependent on an earlier process, which is in this case. So I should go and actually generate code again for this. So now this will take the new context that it is a support vector machine and generate code accordingly. If the coupling is not tight, then we need not generate redo code for the other processes. Like we didn't have to do load iris data and cleanse and pre-process iris data again. As you can see, I tend to run code more in the IDE just to see how things are. So that's where actually what one would do is, I should show you the complete flow. So I might not want to accept this code before I try it out. So I can either run the code over here, and I am getting this error. So I disagree with the code, and I give it the reason, and I submit this feedback. So it takes this along with all the earlier context, and it will regenerate code. And if I want to see, I can see the session summary. So in the round one summary, it says the user rejected the code due to some error. And it summarizes it, of course. And I can again run the code from here. It's successful. We don't see an output over here because a file gets generated. So now I can accept this. And I'll just delete the earlier prediction so we are sure that it is still running. And we get these predictions along with probabilities and the predicted species and stuff. So that's it. Well, so that's how you can use the Dhaani-iProg tool to create an end-to-end data flow diagram and then create code for each of this. This was a very simple iris classification project that we worked on, but usually your project would be more complex, and I suggest spending as much time on the data flow diagram and the specifications of the project and for each of the processes and describing the data stores. As much clarity you have in your information at this stage, it will be that much easier to generate code in the next stage when you're generating code for each process. I hope you found this helpful. If you do try out the Dhaani-iProg tool, please do let me know your experience with it. Thank you.